Okay, so let's start. Hello and welcome to second video in our beginner series for vehicle diagnostics, vehicle communication you can say. So in the previous discussion I talked about why this is not changing. Okay, I talked about uh, how as a English how we started with how to talk with vehicles and various methods, and I provided some analogy to English language in terms of layers. And here we mentioned that English protocol is application layer, like English grammar we can say is protocol and set of words. And there can be various methods like speaking, listening. In this way, like we can draw some analogy to English language in terms of layers. So my point was that vehicle communication is also similar, and it is similar to how we speak in English, how we talk, how we write maybe, and it is divided into layers, and it's well defined. So it's very easy to understand. So we also confirmed, means we concluded that we can say protocol as many things, like a set of rules is protocol, or uh, we can say that method protocol can be a method or way to do something. So the term protocol is like we can use, so this term is very always used in terms of vehicle diagnostics, like protocol. So let's move on and let's see a little bit more about next. So what I want to do is, let's start with very basic communication between vehicle and computer. So we we discussed that how two people talk, like there is some English here and then some talking protocol is here, and then other person should also have that talking protocol, and then he or she should understand English. So basically same things apply for this also, vehicle communication also. And okay, I will just play this for full screen. Okay, better. So here also we have same way we have this English protocol here, English protocol here. So this is our computer application. So we cannot talk directly to some vehicle. So we have some computer application here which is running on Windows or Linux, and this side I have considered a vehicle has a computer. So you can say, for sake of simplicity, that vehicle has only one computer, or in vehicle terminology we call it electronic control unit, or ECU. Okay, so let's have very simple, like there is one ECU, one computer, you can say one computer inside vehicle, and one computer we have in with us. So both computers should have this protocol implemented, application layer, to how to talk, and the talking method also should be implemented, and there should be a connection between them. So here is the cable. So let's move on to next slide. Okay, so but in case of vehicle communication, English is pretty big language, and it is very I would say not the concrete language, means it same sentence in English can have different meanings. So also we don't need English in case of vehicle communication. English is a very broad general purpose language with lots of words, like endless amount of words. Every day we hear new words. So in that sense, like there is a reduced set of words or grammar which we need for vehicle communication. So in this we can see that this in place of English we are using some vehicle words or grammar. For time being, in simple words we can call that. So and here we are saying English protocols, that also need to change, because we already know that the both should know the same language. Like I am communicating to somebody else, so if I am communicating English and that other person does not know English, they cannot communicate, they will not able to understand. So vehicle, if the vehicle is implementing this language like vehicle words or grammar, then our side also we should not use English, we should use proper vehicle protocol. So just tick. Okay, so here vehicle word. So now we have an agreement that okay, this vehicle, we will talk in terms of some vehicle words. Okay, so application layer is sorted. Okay, here we see there should be matching language, so we have a matching language here, some vehicle words, hello, hi, whatever it is. Then we move on to talking method or protocol. So talking method or protocol, here we see that we when we talk to a person, we are using the medium as air, like our voice, our sound is going in the air and the other person is receiving it. But here it is a cable, there can be some computer cable, LAN cable, or anything, Wi-Fi, anything will be there. So this cable is there, and accordingly there will be a talking protocol. So everything is standardized, I would say, like in vehicle diagnostics, vehicle communication, I would say that things are standardized. So as according to medium, the talking protocol is standardized. So I am saying that these protocols, these layers are standardized because let's go little bit why we needed standardization. So basically there are historically there are three main centers, correct me in comments if I'm wrong, three main centers of vehicle manufacturing. So first one is Japan. Japan is almost world leader in this, and I would not give any ranking, just so Europe is the second, and third is US, not third, US. So US, Europe, and Japan. These are three world centers for vehicle manufacturing, and so what happened that when Japanese company is designing a car, a vehicle computer or car, what they're using, they're implementing their own words and grammar. Okay, so European company are developing their own words and grammar, so they're different. US company will be using some other methodology, so they're different. But uh, but this does not go well when you consider globalization, when one car is getting sold, made in Japan, getting sold in Europe or USA, then that car will not be able to communicate to US computers. Or for example, like they don't know their vehicle language because they cannot make any program for communicating with the vehicle. So if a car is sold, made in Japan and sold in US, so the dealers there, how will they talk to the car? They will not be able to talk to car. Also, this was one part. This many use cases will be there which needed some standardization. So in order to make it standard, so that each of these cars can go anywhere and the government authorities can take data from their cars, and also the parts also, like there are many parts which can be, like for example there is one parts manufacturer, like this vehicle computer manufacturer is there, for example some XYZ company, and this XYZ company is making this part. So if some standard is there, then it is very easy for them to implement this grammar, well defined grammar, into the computer, and that part can be sold to US car company or European car company or Japanese car company. So that is that's why standardization was needed, basically. So yes, so already we have a little bit idea, like because of these issues some standardization was needed. Also there are some also there are some things like we can like cost reduction also, like we don't have to redesign the wheel, reinvent the wheel, we can say. Like a new manufacturer is there, for example, so new manufacturer does not have to implement everything again from scratch, so they can use some existing, okay, this is the grammar. Okay, so I can use these words in my car, and I can use this layer, this layer, this layer, and that way I can implement something. And interoperability also, the two things I have mentioned, but there are many things. So interoperability means like one part can be replaced with another part made from some other manufacturer around the globe, and it will be interacting nicely. So so already actually this I have written this OSI model. So this OSI model is Open Systems Interconnect. So actually, this standardization problem is not just a problem in vehicle domain or automotive domain. It was a general problem, and basically, this first model was this was introduced for computer intercomputer communication. So from there, it has evolved into like I can give you some examples. I will just quickly go through that. For example, uh, a PC is made in by Apple, and a mobile device is made by Samsung, and we these are two different manufacturers. So if we don't have any kind of standardization, we would assume that this device cannot talk to this device. As simple as that. So if so there should be some standardization, the language and everything we have to standardize. So there comes the open system interconnect model. There are some other models also, TCP/IP model also. So basically, to solve the problem, the computer engineer scientist already developed this model, open system interconnect. So yeah, then we will be okay. Okay, let's move on to okay. So vehicle communication OSI layer. So I'm just giving a brief overview. I will not go deep. Don't be afraid. Anything. So when I'm saying I'm dividing actually in terms of OSI layers. So like this is OSI layers here this side, and this is the model or layer which we have been discussing in previous video also. Yes, so I forgot to mention that I have been discussing. I mentioned, I think, no problem. So in the previous video, if you haven't watched that video, to get a good grip, you can watch that video again, the first video, and there I have mentioned these layers in terms of human communication. So here we see, let's come back to vehicle communication in terms of OSI layer. So here we see the same computer. So vehicle computer this is, or we can call it ECU, and it has some grammar here which we are calling, we can say that it is application layer, and there will be some talking protocol, and there will be medium. So this talking protocol, you can mention it here. These layers correspond to sorry, these three layers correspond here. Then medium, data link, and physical also. So it's too much here. Okay, so this is basically, so don't be afraid, I will go into slowly into these details. So okay, let's go. So what is the use case for each layer? So the use case for each layer is that each layer has its own responsibility, crystal clear, like it is defined in the standard. And this layer is only meant for grammar, this layer is only meant for timing, for example, and some other layer is doing some other job. And it is because these are layers, it can be easily replaced when a new technology comes for communication or something. So many different things. So let's have it with this human communication example, and I'm taking timing as an example here. So here we have English protocol, and we have this talking protocol as per medium, whatever it is. So let's go to next slide. Then let's take example like in English protocol, when we are using English protocol. So 100% hi, hello, everything will be there. And for example, I have a message hi. Okay, so this message I have to, so there are three ways I can do hi friend, or hello friend, something, hello world or something. So this is the message in terms of English here. So this message is here. Now I have three options. If I use this face to face communication, okay, so face to face means this other person is also here, and it is, they are sitting in front of us or something. Then we have this face to face protocol, face to face communication or direct communication or voice or something, and they also have this English. So what are your expectation for timing here? Like for example, I say hi, my friend name something, hello. So here if we don't receive a reply, for example, somebody is sitting in beside you and you say hi, and that person does not respond within maybe 2 second, 10 second, maybe you will wait for 5 second, maybe if you are, it depends on situation like how long you can wait, but basically you are waiting for some time. Okay, so this is the message, and you're waiting for some time here, in terms of face to face communication. So 10 second, 5 second. Okay, just consider that if you are sending this hi via a chat, what what will you think the timing will be when you are emailing to someone? A good time is not 10 seconds, of course not. So our timing parameter has changed. It can be one day, it can be one day, maybe less than one day, or 2 days, or depend on like if you're emailing to your colleague, you will be expecting one day. If you're emailing to your boss, you can expect longer time to respond. Or if you are emailing to your subordinate, maybe you expect within 1 hour, 2 hours. So these are timing parameters. Okay, so if I am posting a message via postage, so I can wait for months maybe. Okay, month is okay, maybe means old time. Nowadays this, so these are different timing. Even in English we can say that we are maintaining a different time limits for our messages to reach and to us to receive a response. So you can see we need some every time we create a session with someone, here what we are doing is, when we are saying a hi to somebody, we are creating a session. So when we are creating a session, here we are emailing one person, we are creating a session. Okay, I send, what is the status of blah blah blah, other person, then I have started a session of communication. Okay, then that person will reply the according to that. Okay, so this is the status. Then why you didn't report in time, or something like that, why it is not complete, or good done, good work, or something. So this session, and then the session is completed, something like that. So whenever I am initiating communication, I am establishing a session to a target recipient. So I'm emailing to somebody, I'm talking to my friend face to face here. So this layer, which I am talking strictly in terms of like English and analogy with vehicle communication. This layer is session layer. Okay, this layer, what we have in our brains, like everything, this timing is done in our brain. Or if you can't like when face to face, this timing you can use directly. But sometimes maybe you emailed some person and forgot about it, you can check, okay, this date I sent this person, approximately 2 days should response should come, maybe a holiday is there or something like that. So we are maintaining some session and timing parameters in our head, and for this we have session layer. So this was just an example to show that each layer has its own responsibility, clear cut. So our this layer here, session layer, has a responsibility for maintaining session. And if that person does not reply within that session, you can say it is session timeout in technical terms. Like if I'm saying hi to somebody, if the person does not respond in 10 seconds, I will not talk anything else. Okay, so I will say session timeout, connection close, finish. If that person replies in 2 seconds, I may continue that communication. So my session may continue further, like okay, so next message will go, how are you, and how's your family, or something like that. So in that case, session will continue, and timing parameters may change accordingly. So this layer, so let's move to next slide. So here we have this. Now we little bit, I think you understood like what is the task of this session layer, to maintain the timing. Okay, basically. So for example, English protocol here is our application layer. Application, I'm saying application. This session layer, oh, I have reversed, but okay, session layer is for timing. Okay, you can say. So there is, you can say that there is one presentation layer also. I will come back to it. We don't use yet in vehicle diagnostics this presentation layer yet, so I'm not presenting. A presentation layer is basically for encryption, decryption, that kind of, like, you want some security. So what you can do is, when you're sending a message hi, you can encrypt that message so that nobody can understand what that message is. Other person, oh, you can, if you're sending uh, password protected zip file, that can be like a good example of a presentation layer encryption, probably. Tell me if I'm wrong, but just this came into my mind. So presentation layer we can forget here a little bit. So this is the OSI here. Okay, I forgot to mention here. I have put OSI model here, and here if I forget everything and again put, so here is the OSI. We have English protocol, which is application. Sorry, I again have to application layer. This is for timing, and here are our transport network, data link, and physical. So basically you can think that these below, the postage, like if I'm sending something by post, so post will have its own transport layer, network layer, data link layer, physical layer. So all these layers are there. So basically these are layers in OSI: application layer, presentation layer, session layer, transport network, data link, and physical. So email, when I'm doing an email, it will have its own transport network, data link layer. Also it may have its own application layer, something, but let's not go into that. When you will become expert in that, you will automatically understand that there can be many OSI layers on top of, like when we are talking about different applications, we can have separate layers above the layers. So that's how it is. So and face to face also we have this air as medium, and some transportation. So for example, I gave example for timing. Let's take an example for transport and network layer combined. Let's take it combined. So for example, I'm talking face to face with a person. How long sentence I can, how many words I can say before other person will say okay, stop, I cannot understand anymore. So that can be uh, depend on person to person, like 10 words, 20 words, something like that. So that is the task of this layer, to divide the data. For example, I have 2000 words here, I want to say a lot of things, like I'm saying. So if you are observing me, I am forming small sentences, and I am giving time to you to absorb those sentences. If I am not, I'm sorry, please put it in comments. So if I have to increase my timing in inter frame timing, so what I'm giving you is one sentence, you can consider it as frame. So you can send one sentence, you can consider as frame in technical terms, in OSI terms. And when I'm saying sentence number 1, sentence number 2, sentence number 3, so there should be a length of sentence. Okay, so length, like how much other person can understand. So, and there is, for example, this frame number 1, then frame number 2, sentence number 3. There should be some gap also here. So all these parameters are handled by this transport and network layer. I will say transport layer, but broadly, like, don't go too much detail now. Just try to understand like responsibility of each layer. Like I have started a session here. I'm maintaining some timing for each sentence or discussion sentence, and then when I'm saying something, I am in my mind stopping after some time, like 5 words, 10 words, making small sentences. Again the next sentence will be there without, then again next sentence. Or you can consider it as words also, like one word, second word. If I am speaking too fast, like if I'm speaking like this, how you understand this OSI model and everything, so you may not be able to pick up the pace, so you can consider this as word also. So talking and everything, our brain is handling everything, so sentence or word. So this kind of like dividing the entire message into small parts is job of transport layer, transport network layer. And network layer also has the, then we go to network layer. So it is little bit difficult in case of face to face communication. network layer has the responsibility to correctly route the message. So how can I give an example for routing a message? Like when we are talking to another person, we don't have to route so much, but what we can do is we can tell this message to somebody else, and that person can route the message to other. But I can give good example in post, like when we are doing a postage. So our brain is very complicated. So I can, if I deep dive and do a PhD in it, I can derive some model here for network also. But it is possible, like OSI in we can do in face to face also. So postage, we can have this model. If you want, I can explain it now. What how much duration? Already 25 minutes, so it's okay. I've Okay, or maybe I can explain, just a moment. Okay, so in case of postage, there is, let's not make it very complex. So what our basic understanding is, let's revise one time. So please go away. Okay, so here I have put one example, but forget about this side. And so application layer is vehicle words or grammar, session layer is for timing. Timing, this is session layer here. Then transport layer divides the message into parts. Network layer routes the message, like how the message will reach to another party. And there is medium, so here is cable. So here are our OSI layers here, and I'm just giving this example here. Like there is one protocol called UDS. UDS is very famous and almost standardized in the world. Unified Diagnostic Services. Okay, Unified Diagnostic Services, very colorful. So it has its application layer, which has the grammar. It has its session layer, which has the timing parameters. Then there are transport and network layers. Different layers we can use depending on technology. And data link and physical layer. So if it is okay, if you are understanding, just you can little bit go back if you are confused or anything else. I'm just giving an example of actual vehicle communication OSI stack. So what I'm doing is, this is a stack. Okay, so this is stack because what is a stack? Like one thing on top of other thing is a stack. So when I have to make a stack for vehicle diagnostics, I will choose which standard I want to use, which grammar I want to use, which session layer I want to use, which transport and network layer I want to use. It is very plug and play. It is very good actually, because I have mentioned that each layer has its responsibility clear, and these are replaceable. It is beautiful. So that any task you do, if you try to divide into layers, it will be very useful. So and you can distribute this task, like I can, it's okay, it's too far, going too far. So this we call a stack. Okay, and here we can see this we can call as stack. In English we can call English protocol, speaking, listening, and the medium is air as a protocol stack, if you are visualizing that. So this is also a term like stack, protocol stack. So we were talking about protocol. So in each individual element is a protocol, these layer. Okay, this is application layer protocol, this is session layer protocol here, then transport and network layer protocol, data link and physical layer protocol, and completely it is a protocol stack. Okay, I hope it is clear. If not clear, please. So I don't want to make all of you afraid, but this is how I was saying that these are replaceable, and it is very easy to replace one another. So you can see the application layer we have kept same here. So these are three protocol stack. For example, stack number one. Oh, please stay. Stack number one. Okay. Stack number two. Stack number three. 1 2 3. Here you can see like the application layer is same in these two stacks. Here we have changed the application layer. No need to worry why we have changed. We can have uh, these kind of plug and play modules, and then session layer is almost same here. So here I have mentioned this Diagon CAN protocol. Okay, and this Diagon CAN protocol, here there is DOIP protocol instead of this Diagon CAN. Here you can see, and here I'm using Ethernet as a communication medium, and here I'm using CAN. So it's all about the stack you are using. So if any vehicle manufacturer is developing one computer, it will choose its stack. Okay, so if some company XYZ chooses that, okay, I will develop my ECU using this stack. ECU is vehicle computer or electronic control unit. I will write it here again. ECU, electronic control unit or vehicle computer. So entire stack makes up it. ECU with hardware and sensors. I should discuss what are the tasks of ECU also. So each vehicle manufacturer or ECU developer, computer developer selects its stack, communication stack, diagnostic stack, I would say. So that's about it. I think it's good here. I think if you have any doubts, so I will, in this slide is covering a lot. Okay, this is like understanding entire, this is the entire vehicle diagnostics. This is entire vehicle diagnostics, like communication part at least. So if you are able to watch this in one slide, it is very big. So don't be afraid, but it's very easy also once you understand what each layer does, what is the responsibility of each layer. It's very easy to understand and correlate, okay, how this thing is. Okay, so for example, timing will be, okay, timing will be in this layer. Okay, grammar will be in this layer. Okay, no problem. So if I have to divide my big message into small packets, understandable packets, so these are the layers. Our routing, how the message will go and reach the target, so these layers will do something. Okay, then we have the physical layers. So these layers handle the physical aspect, like how the uh, our message will convert it into signals and digital 0101 binary or voltage level, whatever it is. So these are well defined because that is also important. So simple, I hope you understood. Grammar, timing, division into packet, routing, physical layer, conversion to electronic voltages or something like that. As simple as that. So I hope you understood. If you have any doubts, please put a comment. Please like the video if you understood, and I will be proceeding in detail, maybe next video about some ECU, like what is the basic things or something like that, or I'll decide like if I can start with some of the layers. But I think first I should go to ECU and other things about vehicle diagnostic before jumping into exact layers and deep dive into. Thank you so much. There was one question. Okay, there was one question that where is the thinking layer after English? So I want to say thinking layer is what we call as business layer or business logic. So for example, a message is received to you, hi, hello, then you think about it. It's above English. Okay, so English is here, and after above that you have thinking logic, and it depends on the which task you are doing. So for example, if you are discussing about planning a vacation, so you are talking in English, but the logic you are running is related to planning a vacation or booking a hotel. So if I ask somebody, please give me quotation for blah blah blah, how much the room will cost, the person will reply according to stack in English. And that message, when I'm sending that message, uh, message message, so what will happen, that message will reach to that person, to the top layer, English layer, and above it will go to its business layer. So it will understand the message. Okay, thinking layer. Then it will say, okay, what is asked? The other person is asking charges or cost. Then it will say, okay, this cost for one night or something, like room charges will be like this, food charges will be like this, and this message will come again by the stack, then come back to us. We will process this along the stack, and we will understand the English, and after that we will go to our business logic layer, which is thinking layer. So it depends on the application, like what you are doing. A brain can do lots of application, like we can drive, we can eat, we can plan, we can discuss political topics. So business logic will change according to what you are discussing or what you are communicating to. So business logic can be political, business logic can be economical, economics, or anything. So this is my understanding. If understood, please put a comment. If not, I will explain it more detail. Thank you so much. I hope this video has been long, but I hope this will be a good uh, follow-up video to the first video, and I hope I have kept the thing simple. uh, if not, please put a comment that which part was too much for you. I hope, and if you don't understand, I would say, like, you can rewind a bit, or if you are totally forgot like how English is comparable to these layers or something, you can watch the first video also. Thanks. Thank you.